Today we are discussing one more important topics in the network analysis or circuit theory, that is current division rule, where we are applying current division rule. Okay. So first we'll derive the equation. Let us take two resistors are parallel, and you know how to find I1 value, I2 value. If you know the total current, how to find I1 value, I2 value. First we'll derive this equation. So when two resistors are parallel, what is the equivalent resistance? From this equation, we can write as R equivalent equal to R1, R2 divided by R1 plus R2. R equivalent. Two resistors are parallel. Series means just R1 plus R2. Now, how to write supply voltage? Supply voltage we can write as Vs equal to total current into R equivalent. Vs into I total into R equivalent. Assume this is equation number 1. How to find I1 value and how to find I2 value? So here, these are parallel. Voltage across R1 also Vs, voltage across R2 also Vs1. Now, what is the current through R1? We can write as I1 equal to Vs by R1. This current we are writing in terms of V by R using one. What is Vs from the equation 1? Just substitute this one. I1 equal to Vs value I total into R equivalent divided by R1. What is R equivalent value? R1 R2 by R1 plus R2. Therefore, I1 equal to I total into R equivalent value R1 R2 divided by R1 plus R2 into 1 by R1. If you simplify this one, you will get I1 equal to I total into R2 divided by R1 plus R. This is one equation. Similarly, how to find I2 value? I2 equal to Vs by R2. Vs by R2. What is Vs value? I total into R equivalent value R1, R2 divided by R1 plus R2 into 1 by R2. So we'll get I2 equal to I total into, that is R1 divided by R1 plus R2. Yeah. Just this derivation not required, but how to remember I1 value, I2 value? If we know the total current, I1 value equal to total current, I total current multiplied by opposite resistance. We are finding current through R1. For this one, opposite resistance R2. R2 divided by sum of the resistances. Similarly, I want to find out I2 value. If you know the total current, how to find I2 value? I2 is the current through the R2. For this one, opposite resistance R2, R1. Therefore, I total into R1 divided by R1 plus R2. Just total current into opposite resistance by sum of the resistances. Just remember this formula. Almost in all network theorems, we are using current division rule. This is very, very important. Whenever, if you know the total current, just apply current division rule. Total current into opposite resistance by sum of the resistances. Just remember in the words only. Total current into opposite resistance by sum of the resistances. How to apply current division rule in problems? Let us take some word questions from the different university question papers. First problem. This is the problem. In this problem, determine I1 value using current division rule only. One of the JNT old question paper. How to find I1 value? I1 is current through the 5 ohms. Given the total current 36 ampere. 36 ampere. Okay. Total current given 36. So, first find out this part equivalent resistance and find out the I2 value. So what is the equivalent resistance between this point to this point? Okay, from here to here, what is the equivalent resistance? Assume this is A and this is B, between A and B. RAB equal to 6 parallel to these two are parallel, that is 20 is parallel to 5. 20 is parallel to 5, you will get 4 ohms. 4 into 6 you will get 10 ohms. So between A to B, total resistance value is 10 ohms. 6 plus 4, 10 ohms. Okay. Now, first we will find out the I2 value, then we will find out the I1 value. So here the total current given 36 ampere. What is I2 value? Okay. I2. What is the current division formula? Total current into opposite resistance by sum of the resistances. So here total current given 36 ampere. Okay. Otherwise write down the formula. Okay, not required. Total current 36 ampere. For this one, opposite resistance is 8 ohms. 8 ohms. And divided by sum of the resistances. 8 plus between A and B, 10 ohms. That is 8 plus 10 ohms. Because this is the opposite resistance, 10 ohms to 8 ohms. 8 and 10 are parallel. Now, what is the I2 value? Approximately you will get 16 ampere. 16 ampere. I2 is the 16 ampere. Now, in the problem, we have to find out I1 value. I1 is current through 5 ohms. How to find I1 value? Now, here 20 and 5 are parallel. So, for 5 ohms, opposite resistance 20 ohm. Here the total current is I2. I2 we got 16 ampere. Now, apply again same current division rule. What is current division rule? I1 equal to, here total current is I2 and 5 ohms opposite resistance 20 divided by sum of the resistances 20 plus 5, that is I2 value 16 into 20 divided by 25. This is plus only. Plus 5. After calculating this one, approximately will get 12.8 ampere. Okay, this is one of the world question from the JNT question paper. Okay? Just if you know the total current, how to find equivalent resistance? Total current into opposite resistance by sum of the resistances. Okay? So between A and B, first to find out the equivalent resistance between A and B. 20 is parallel to 5, we get 4. 4 and this combination 6 series 10 ohms. Now I2 is the current through 6. So if you know I2 value, you easily will get I1 value. How to find I2 value? Apply current division rule. Total current 36 into, for this one opposite 8, 8 divided by 8 plus 10. You get the answer. Similarly, I1 is the current through 5. Here total current is I2 and for 5 ohms opposite is 20 ohms. Substitute the values, you will get I1. That's a very simple problem. We will take one more problem using current division rule. Yeah. So in this problem, determine the voltage across each element. Determine the voltage across each element. So first we have to find the total current. Find the total current and divide the current using current division rule. How to find total current? First to find out the equivalent resistance between these two terminals A and B. Between A and B, find out the equivalent resistance. So how to find equivalent resistance? Already you know series parallel combination. R equivalent equal to, these 3 and 6 are parallel. 3 is parallel to 6. This combination in series to 18 and this whole combination in parallel to 5. In parallel to 5. And this whole combination in series to 8 ohm. 8 ohm. Okay, is it clear? First 3 and 6 are parallel. This is combination in series to 18. Now, up to this one, 3, 6, this is you get 2, 2 plus 18, 20. 20 is parallel to 5. Again, whole combination in series to 8. So, what is the answer? 3 is parallel to 6 means you will get 18 by 9, 2. 2 plus 18, 20. 20 is parallel to 5, you will get 4. 4 plus 8, you will get approximately 12. Approximately 12. Okay. Very simple. 3, 6 are parallel. R1, R2 by R1 plus R2. 18 by 9, 2. 2 and 18 are in series, 20. This 20 is parallel to 5. 20 parallel to 5, you will get 4. 4 and 8 are in series, you will get 12. Now, we have to find total current. Whenever we are applying current division rule, we have to find total current. I total equal to supply voltage by R equivalent. So, here supply voltage given in this problem 60. 60 divided by 12 will get 5 amp. So this is the total current. Total current 5 ampere. 5 ampere. So from here current is dividing. Assume this current is I1. Assume this current is I2. And assume this current is I3. And assume this current is I4. So we have to find I1, I2, I3, I4 using current division rule. So current through 18 also same current, that is I1 only, and this is the total current same as 5 ampere. 5 ampere. If you know the current, voltage across each element is I into resistor. Find out the values. Okay. First, how to find out I1 value? So I1 value from here to here. First find out the, assume this is junction C. Assume this junction D. Between C and D, find out the equivalent resistance. Between C and D. R, C, D. C and D. 3, 6 are parallel. 3 parallel to 6 in series to 18. So, that is 18 by 9, 2 plus 18, we will get 20. Between C and D, that is 20 ohm. Now, how to find I1? Here the total current is 5 ampere. Okay. This is I1 and this is I2. This is I2. Yeah. First we will find out the I1 value. So, I1 value equal to total current is 5 ampere. And for this CD combination, opposite resistance is 5 ohms. 5 ohms divided by sum of the resistances. Between C and D, resistance is 20. 20 plus 5, 25. 20 plus 5 will get 1 ampere. This is I1 value. So here, total current 5 ampere. I1 1 ampere means what is the remaining current I2? 4 ampere only. I2 will get 4 ampere. I2 4 ampere. Now how to find I3 value, I4 value? Okay. So I3 value, I4 value. Here I1 is the total current. For I3, opposite is 6 ohm. For I4, opposite is 3 ohms. Now, I3 equal to total current here I1. Opposite resistance 6 divided by 6 plus 3. I1 already got 1 ampere. Therefore, I3 will get 0.666 ampere. Similarly, I4. I4 is the current through 6 ohms. That is total current I1 into 3 divided by 3 plus 6. So, you will get 0.333 ampere. 0.3333 ampere. So you know all the currents. Find out the voltage across each element. So we have to find voltage across each element. You know the current values. Find out the voltage across each element. Suppose I want to find out voltage across 3 ohm. Voltage across 3 ohm equal to current through 3 ohms is I3. I3 into 3. And voltage across 6 ohms. Voltage across 6 ohms is I4 into 6 ohm. Similarly, voltage across 18 ohm. Voltage across 18 ohm is I1 into 18. Next, voltage across 5 ohm. Voltage across 5 ohm is I2 into 5. I2 into 5. Voltage across 8. Voltage across 8 ohms is 8 into 5. We'll get 40 volts. Remaining values, voltage across 3 ohms is approximately will get 1 volt. Voltage across 6 ohm, approximately will get 2 volts. Voltage across 18 ohm, 1 into 18, you will get 18 volts. Voltage across 5 ohms, that is I2 you got 4 ampere, 4 into 5, 20 volts. Okay. That's all. So, current is very simple. First to find out the total current. Okay, when two resistors are parallel, total current into opposite resistance by sum of the resistors. Just follow this method. This is very simple. I think superposition theorem, Thevenin's theorem, Norton's theorem, we are applying current division rule. That's it.